Graph each linear inequality. So when you first look at a linear inequality, the first thing you should look for is what is the boundary line that cuts off my axis into a half plane. So if I look at this linear inequality, the boundary line is y equals -4 if I replace the inequality sign with an equal sign. And I know y equals -4 is all points where y equals -4. So I'm going to plot those points. So now I look at my inequality sign. Since that inequality sign is saying we want to be less than our boundary line, we're going to shade below a dashed boundary line, because we do not want to equal our boundary line. We just want to be less than that boundary line. So I'm going to connect these points with a dashed line. And I want to shade all y values below this line. So if I look for some possible solutions, it will be any points below this line. So if I plot this point, that is -4, -4. Or if I plot this point, that would be 0, -4. Or I could go a little further down and say that 0, -5 is a solution. So there are an infinite amount of solutions shaded below that boundary line. So if I look at number 21, now I first want to figure out what is my boundary line. My boundary line is y equals -x plus 0. Looking at that boundary line, I know it has a y-intercept of 0 and a slope of -1/1. So I'm going to start at 0, my y-intercept, and I'm going to go down 1/1 to plot all of my points. Down 1/1, down 1/1, down 1/1. I can also go backwards, left 1, up 1, left 1, up 1. So now what I do is I look at my inequality sign. And since that inequality sign reads as greater than or equal to, I want to shade above a solid boundary line. So that means since I'm equal to my boundary line, it's going to be a solid line through these points. But now I want to shade all y values above this line. Above and including the line is my solution. So this entire half plane is my solution. So remember, there are infinite solutions. So I could plot one here, right? And that point is 2, 1. Or I could pick a point here, 1, 4. I also could pick a point on my boundary line because that line is included in my point, in my solution set, 2, -2. But there are an infinite amount of solutions for this linear inequality.